It's 11:40. Let's get started. Welcome, everyone. Thank you for joining this session about Git. Let's just jump into it because I have a lot of stuff to show you guys. So first, my name is Enrico Campidoglio. I'm a freelancer. Here is me freelancing from home. I also do a fair bit of training, like workshops, conference talks, Pluralsight courses, stuff like that. And these days, everything is done from home. Who would have thought? The other thing to know about me is that I'm really passionate about Git, of all things. And I'm also really passionate about keyboards, but that's another story for another time. However, feel free to ping me if you also share this interest in either Git or keyboards. Anyway, so let's talk about Git, shall we? By the way, everything that I do that has to do with Git, I tend to write on my website, which I'll give you a link for afterwards. Okay, so the thing with Git is everybody is using Git these days. That's no surprise. It has become the de facto standard version control for everyone. However, you may or may not have noticed that while everyone, including me, is busy telling you how Git works internally, nobody is really focusing on how you should actually use it on your day-to-day work. So to give you a metaphor, imagine if you're learning to play an instrument like, for example, the piano, and you know everything about how the piano works, everything from the ground up, and you maybe know each individual note, but then you don't know how to play a full song with it. So yeah, that doesn't really cut it. So what we need is guidance, okay? Guidance on how to use this fantastic tool called Git. But wait a minute, you say, and I can almost hear you from here. Do I need guidance to use a source control system? I mean, I'm a software developer. I know how to check in and check out code. And yeah, you will be right. After all, if you've been using any of the many other source control systems out there, like for example, CVS, Perforce, or everybody's favorite TFS, you should pretty much know how to use a source control system. So why in the world would you need guidance on how to use Git, which after all is a source control system? Or is it? Because the thing with Git is that Git is actually not a source control system from the beginning. If you look in the manual, Git is actually a content tracker. Also a stupid one because it's embarrassingly simple. So Git is all about tracking the changes that happen to files on your hard disk. It's not really a source control system. It looks and acts like one, but it's not really it at the basic level. So it also means that Git doesn't really have an opinion on how you use it, while all the other source control systems before, by virtue of how they were designed, they were pretty much forcing you to use them in a certain way. Git is more like Lego in the sense that it's whatever you make of it. There is no one true way to use Git, like there is no true one way to use Lego. I mean, after you learn the basics of putting two pieces together, it's whatever you make of it. So Git is a very flexible tool, which also means that you can use it however it fits you. And here is where the other problem lies. Okay, so you are telling me that Git can be used in pretty much any way I want, but how do I know which way I want to use it? And here is where things get a bit tricky. So what you can do is observe how other people are using Git, how it's working for them, both individually as well as in their projects, like working with other people. So how are other teams using Git? And what works and what doesn't work? And once you observe all these things, you write them down. which is exactly what I've been doing. And you apply that knowledge to your own experience, and in that way, you sort of grow the way to use Git that fits your needs and the needs of your team and the project. So, with all that out of the way, what is this talk about? This talk is a collection of Git habits, so to speak, that are aimed at improving your development workflow. And these habits, I have collected them by many years now of observing how people are using Git and what works and what works maybe less. And these habits, they apply on two levels, because Git, I'm sure you know, is a distributed source control system, which means it has always two dimensions. You use it on your own computer individually, and that's one dimension. And then you use it in the context of a development project, and that's when you use it inside of a team, when you're collaborating with others. So all these habits, they start with you sitting on your computer, and then they expand into the collaboration aspect. So that's how I organized everything that I'm going to show you in this talk falls in either one of those two categories. So let's get started, shall we? I talk way too much. So I told you that there is an individual dimension for using Git, and I call that dimension personal workflows. The collaboration aspect of Git, I call them team workflows. So these are the two main pillars for this talk. And to give you a little bit more structure, I organized my content in 3 categories of workflows that you can use individually, and 3 categories of workflows that apply to your team. And they sort of build on each other. So without further ado, let's get started with the first one. And for that, I'm gonna jump right over into demo mode. So what you see on the left side, which is here, which might as well be your right side. I'm not really sure how this mirroring works. Anyway, on one side, there is a console, a terminal. And on the other side is where I'm going to show you the text for what I'm trying to tell you. So keep an eye on both those two. And so am I wondering, are you telling me that everything that I'm going to look at today applies only to the command line? Well, no. What I'm going to show you, most of it applies just as well to both the command line as well as if you're using it through any of the many graphical user interfaces out there. And if there is something that just applies to the command line, I'm going to highlight it for you. So let's get started with the first category of personal workflows, and that is get comfortable. So what does this mean? This means that you should configure Git exactly to make it a more comfortable tool to work with. And in this first category, and this applies just if you're using Git on the command prompt, is to install a Git aware prompt. Now, what in the world is that? A Git aware prompt is simply a script or some kind of utility that enriches your command line and adds information that is Git specific. So for example, you see over here that I'm looking at the name of the branch I'm on. And as you see later throughout this talk, that information is updated as I modify files and I pull changes and push changes and stuff like that. So having that information right in front of you at all times certainly helps. Now, what prompt should you install? Well, that depends on which operating system you're on. If you're using Windows, and maybe you're using the new Windows terminal, and you're using PowerShell as your shell, then I highly recommend that you install PoshGit, which is a Git-aware prompt for, of course, PowerShell. If you're using Linux, then there is bash git prompt, which is everything is open source, of course. And then there is my personal favorite, Starship, which is the one you are looking at over here. And Starship is cross-platform, so you can use it everywhere. So that's the first one. The second one is, I call it pretty diffs. Now, and this also applies only to the command line, because if you're using a GUI, then that's the thing that's going to show you the diffs. So when you use Git, you're going to look at a lot of patches, differences between two versions of the same file. Now, there is no reason why you shouldn't make it as pretty as possible. So, for example, let's go ahead, and I'm going to tell you right away what it is I want to say. So, there is an npm module which is called diff-so-fancy, which you can install by saying npm install -g diff-so-fancy, G for global. Once you've done that, you need to tell Git to pipe all the diff information through diff-so-fancy before it gets printed on the screen. And the way you do that is by setting the core.pager option. So here you're basically saying to Git, all diff information should be piped through diff-so-fancy, and then of course it pipes it to less to give you paging and the ability to scroll up and down. Now, once you've done that, your diffs are going to look much better than before. So to demonstrate this to you, let me first compare the commit that came before the one I'm currently on with the one I'm on right now. And now I have already configured diff-so-fancy, so I'm going to tell Git to ignore the pager right now to just show me how a regular diff would look like. And of course, you recognize this format. You have a bunch of header information over here, and then you have the classic plus and minus for modified lines. Now, this is fine for most cases, but we can do better. So here is how it looks like once you have diff-so-fancy activated, which of course, it's obviously much better. It also shows you exactly which part of a line has been modified between two versions by highlighting it for you over here. So, yeah, definitely prettier diffs. Moving on, speaking of making your environment comfortable, is to let Git handle whitespace for you. Now, as programmers, we all know that whitespace matters. Well, it turns out that Git has built-in features to make sure that your team, once you're agreed upon how you want to, for example, handle indentation, to make sure that everybody on your team is conforming to the agreed upon whitespace handling rules. So how do you do that? Well, there is an option called core.whitespace. And in this option, you are basically telling Git what it should consider to be invalid whitespace. So in this case, core.whitespace, in this case, I'm telling Git that I don't want any whitespace at the end of a line, and I don't want any whitespace at the end of a file either. And of course, my favorite one is that I don't want to see any tabs used for indentation, only spaces, which is, of course, everybody knows is the correct way to do indentation, right? So once you've done that, you can basically, every time you modify your files, you can do a quick check using the check option of git diff, and Git will tell you if you are breaking any of those rules. So for example, let me open up this. This is just a C# program that does basically nothing. So let's change something and add a bunch of white space. So maybe I'm adding a comment over here, and then at the end of the line, I add a bunch of white space in the end. So let's save this. And if I now say git diff check, Git is telling me, hey, you have trailing white space, and it even tells me on which line. So this gives me the option to fix it before I commit it. And as we're going to see later on, you can also automate this step. So you don't have to remember to every time run diff check. So the next one is conflict handling. Now, of course, if you are working in a team, you are sooner or later gonna run into merge conflicts. They are just a fact of life. Now, Git is famous for being very good at handling merge conflicts. And why? Well, because it's a distributed source control system where everybody is working asynchronously. So the chances that you are going to have merge conflicts are even higher than if you had a traditional centralized source control system where, for example, you have exclusive checkout rules where only one person at a time can modify a file. So let me just get rid of the change. So what can you do? Well, the default way of showing you merge conflict, and this applies both to the command line and as well as if you're using a GUI, is to show you each side of the merge conflict. So in this example, I have another branch called feature, and I know for a fact that this branch contains a merge conflict. So let's go ahead and try to merge feature into master, and here we go. We are having a merge conflict. So let's take a look at how the diff looks like. And of course, you recognize this. You see how the conflicting line looks like on one side of the conflict, and then you see how it looks like on the other side. Sometimes this is enough to be able to decide what the final line should look like. However, Git can do better than that. There is an option which is called conflict style. And if you set it to diff3, Git is going to activate its three-way merge feature, which is absolutely the best. So let's do it. Config merge dot, I don't know why this is not the default, by the way. Beats me. Conflict style, you set it to diff3. And now let's do the same merge again. Sorry, I was in the middle of the other merge. So let's abort that. And let's merge feature again. Of course, we're getting the same conflict. So let's take a look at how the diff looks like. And now I have three versions of the line. I have the one side and the other side like I did before, but now I have the common ancestor, which is how did this line look like before either one of those two commits. So this is really helpful in deciding, okay, how did the common parent of those two commits, how did the line look like in that one, and how was it modified in the two conflicting commits. So this is information that is going to help you resolve the merge conflict. So really awesome stuff. Enable it because yeah, it's great. This concludes the first part of category of personal workflow, of configuring. These are just a few of the options. There are many more, but these are just a few of the options that you can enable to make Git a more effective tool to work with. Let's switch gear and talk about the second thing regarding personal workflows, which is craft your history. Now, this is regardless if you're working on a project by yourself or you're working in a team. However, if it's on a team, it's even more important, is to take care of ensuring that the history of your source code is readable, not only by you, but of course by your teammates and future generations of programmers that are gonna have to work on the code base. Now, what does it mean to have a good-looking history? Again, by observing how many different teams work with Git and in different kinds of projects, I have identified 4 traits of a good-looking history. And those 4 traits make up the acronym ACID. So it's nice and easy to remember. So the first one, the A, stands for autonomous. And this means that each commit should make one logical change. Doesn't mean that it's one physical change. I mean, of course, you can have many modified files in a commit, but all those changes must be related to the same thing, to the same goal. And that should be independent from what other commits do. Now, to do this, there are two ways to do this. Way number one is that as you're working on your source code, you are really disciplined and you do just one thing at a time. For example, if you're fixing a bug, you're not also making a refactoring. You fix the bug and then you create a commit and then you go back and do the refactoring. So by being really disciplined at all times, that's one way to make sure that every commit does one thing. That's a lot to ask. The other way is you work just the way you prefer, you do your own thing, and then at the time of commit, you split your changes so that they are in different compartments. So you isolate each logical change from the others. How do you do that? So let me just change to a different directory. Here we have the same project with the one source code file called program. So the first way to do that is by doing a so-called patch commit. Now, and this is something that you can do either on the command line, and a lot of the better Git GUIs, they also let you do this graphically. So how do you do it on the command line? Let's say that I'm opening up this source code file, which is the same as before. And now I am looking at it and I'm seeing that right over here, there is a syntax. Well, this doesn't even compile. So that was one hell of a bug. So there is an error here. However, while I'm looking at this error, I'm also noticing that, hey, maybe this using statement is unused. Of course, I'm not going to let it be there. I'm going to remove it. So I want to make these two changes, and those are two logically different changes, because one is a functional change, this one over here, and the other one is more of a, you can call it a refactoring. I'm removing an unused line of code. So I'm not going to do it one at a time. I'm going to do both at the same time since I'm working in this file. So let's go up to line 10. Let's remove this. And then let's go to line 9 and let's add the I that's missing in read line. So now if I do git diff, I see that I have two different changes. Now I want to commit them separately from each other. Now, if this was any other source control system, I will have no choice but commit everything at once. In Git, instead of saying git add and then the path of the file, I can add the patch option. And what Git does, it looks at the total number of changes, the diff, and it splits them up, and it's asking me, hey, do you want to stage this hunk? And here the word hunk doesn't mean what you think it means. It means a hunk in the universal diff format, which is a standard. A hunk is just a section of a patch file. So do you want to stage this? And then I'm going to say no, N for no. And then it goes on to the next one and say, do you want to stage this hunk? And then you say yes with the Y. And once you've done that, you see that my Starship Git prompt is showing me that I have one staged file and one modified file on my working directory. So if I do git status, I see that the same file is simultaneously staged and unstaged. So how can I look at what's about to be committed? I say git diff stage, and this is showing me the stuff that I've staged, which is the bug fix. And if I say just git diff, it's showing me what's left in the working directory, which is not going to be committed. So pretty useful stuff. And as I said, you can do this through many of the better, more powerful Git GUIs out there. The next one in the ACID acronym is correct. Now, what does it mean? It means that every individual commit should not break the state of your project. That means it should not add any compilation errors, nor should it add any failing tests. But how do you ensure that every individual commit doesn't break things? And by the way, why would you want to do that? Well, if you imagine a scenario where in your team you have people working on multiple branches, and maybe one of your coworkers is working on a feature branch and is also at the same time fixing a bug that you also have on your branch, maybe you want to just pick that one commit, because every commit is autonomous. You want to pick that one commit that fixes the bug and none of the other commits that add the feature. And you want to apply that on your own branch so that you can, continue working. Now, in order to be able to do that reliably, you need to have this common trust in your team that everyone's commits, you can apply them to any branch and you won't have to deal with the compilation errors or failing tests. That's a basic assumption for this to work. And if everybody agrees on this, then you will be able to exchange commits with each other and keep on working in a more effective way. So that every commit is correct is is fundamental to being effective when working with others. But how do you ensure that every commit by itself doesn't break anything? So one way to do it is to use the stash. Now, if you may or may not know about the stash is a third place, the other two being the index, the staging area, and the commits. It's a third place where you can save modified files. Now, there is one lesser known feature in the stash that's called the keep index. What this does is, well, let me just show you. Now I have staged a change and then I have another change that's not going to be committed. However, it's still on my working directory. Now I want to make sure that this change by itself is correct without and also exclude anything else from my working directory. So the way to do that is to say git stash save, and then I tell Git, you know what, stash everything that I have in my working directory, but keep the index untouched. So when I do that, and I say git stash list, now I have a stash with the change. However, if I look at the index, that my staged change is still there, which means, and that's all I have. So if I look at the status, you see, I no longer have anything modified in my working directory because that's been stashed away. So what you can do now is that you can run your build script. In this case, I just have .NET build and verify that what's about to be committed indeed doesn't break anything. So now I can go ahead and say commit m fixes debug compilation error. But then I want to get back my changes from the stash, of course. So at this point, I say git stash pop, and it's being dropped from the stash. So because you don't want to accumulate too much stuff in the stash, it's like the attic. Everything you put there stays there forever. So you want to remove it from that. However, you want to put it back in your working directory. So now, if I do git status, I have my change back. So that's great. Let's get rid of that. Another thing you can do is that when you're working on a feature branch, you're gonna be making a bunch of commits. Now, maybe you have forgot to run this keep index step because it is an extra step on your workflow, of course. So how can you ensure that what the commits you have right now in your branch individually don't break anything? And this is where the rebase command come in. of all things. Now, the rebase command is probably the most infamous one in among all Git commands. And that's probably because it does too much. It doesn't follow the single responsibility rule. The Git rebase does a bunch of things. And one of the things it does is it allows you to run a command after each commit in a sequence. So let me show you what I mean. So if I look at the history of my branch, and I'm working in master, but if I look at the history of my branch, I know that at some point, one of these commits broke things, because right now, before I fixed the compilation error, I had it in my branch. So one of these commits over here is breaking things. Now, how do I know which one breaks? This is where git rebase comes in. If I say git rebase, and then in this case, I want to go back all the way at the beginning of the history, so I say root. Otherwise, you can specify what is the starting commit that you want to check. And then you say exec, and then you specify which command do you want to run for each of those commits. And of course, if you have a build script, you will run your build script. In this case, I'm just going to run .NET build. And you don't have to do it interactive, but I'm just going to add it. So to show you what it does, interactive. So here are the commits included in the sequence. And you see for each one of them, Git has added the command that I specified. So this means that Git is going to go back to the first commit and run .NET build with the changes included there. And if the .NET build command exits with 0, which means everything went fine, it's going to move on to the next one, and so on until the last. If the command you run exits with something other than 0, this means that something went wrong, and the rebase command is going to stop right at the commit that broke things, just like it will stop if you encountered a merge conflict. So let's just go ahead and run. And this running for the first one, everything is fine. And now it stopped and it said execution failed. And here is also where having a Git aware prompt really helps. It's telling me I'm at commit 4 of 10. And then I can inspect the commit that I'm at right now. And indeed, this is the commit that introduced the failing line. And now I have a chance to fix it and continue the rebase. Pretty awesome stuff, if you ask me. So let's move on to the I in ACID. That means incremental. What does it mean? It means that as you are building up the commits in your branch, in your feature branch, or bug fix branch, or whatever it is, you want those commits to show your the logical progression, your thought process, so to speak, that went into those changes. Why do you ask? Well, because if someone is going to look at your history, they're going to look at a sequence of commits. And if those commits are in the order in which things that in an order that makes sense. For example, if I'm going to do a refactoring, I'm going to do it first. And if I add a feature, I'm going to do it afterwards, not the other way around. It's going to help to understand how the code transformed from one stage to the other. But how do you do that, you ask? Well, meet rebase again. And in this case, we're just using the rebase interactive, like we just did, to reorder the commits in a branch, or possibly if two commits are actually making the same change, which means they're not autonomous, if you remember, you can squash them together and turn two commits or more into one. So in this case, we know that we just run git rebase exec, so we know that the second commit broke the code. However, we fixed it over here. Now, we haven't shared this history with anyone yet. It just exists on our computer, well, on my computer. And so we have a chance to go back and rewrite history so that this commit never actually broke anything. So we want to take this one and make it so that it becomes part of the first commit. And how do you do that? Well, you say git rebase interactive, and then in this case, I'm going to start from the beginning again. And what you do, this is called the to-do file, by the way, because you're telling it, okay, what should happen for each one of those commits? You take this one over here, and you literally move it up to be below the commit that you want to squash it into. And then you say fix up. Now, what does fix up mean? It says it right over here. It squashes the commit, but discards the log commit message. Because, of course, if you're going to make this commit part of the previous one, we're not really interested in keeping this commit message around. So once you've done that, you can save. And by the way, you can do this interactive rebase also through the Git GUIs. And that was really quick. So let's look at our history again. And now you see that that commit is no longer here. It got squashed into this one. So let's look at this commit. Let's look at its patch. And you see that it still adds the line, but now it's adding the correct line and not the wrong one. The last one in this first section is the D, and that stands for documented. What does it mean? Pretty self-explanatory. It means that we know that every commit should make one logical change, isolated from the other. They should be correct, but they should also state with as much detail as possible what it is that they are changing. Now, it turns out that you do that, of course, in the commit message. It turns out that there is a format to how you should format your commit message. And what format is that? Well, first you should have one sentence which is nice and short, and this just describes at the highest level what this change is about, and that's called the summary. And the summary should be at the most 50 characters. After that, you keep you set an empty line, and then you have this so-called body, and the body can contain any amount of detail that's necessary to understand the change. You can also if you have of course, if you're working in a team, you're going to have an issue tracker. You can also mention the issue tracker number in the body. And something that I've seen some teams do is that if you are doing pair programming, Git by default just records one author for every commit. But if there were two of you working on that change, maybe you want to record both of the authors. Well, the way you do that is in the body, you can add a field which is one or more co-authors. And then you basically follow the same Git format for the author with the name, last name, and the email address. And in this way, you can specify other authors that were involved in that commit. Pretty useful, because if the original author maybe is no longer with the company, you have one or more other people you can ask about the background information of that change. The third and final category for the personal workflows is automation. Now, Git has a lot of automation built in, and you should really take advantage of it to automate the workflow, both that you decide to work with on your own, as well as your team workflows. Now, the first one in this means, of course, letting Git do the work for you. The first one is alias functions. Now, you may have heard, and this only applies to the command line. You may have heard about Git aliases. So, for example, if you don't want to type checkout every time, you can define an alias called, for example, CO, and now you can say git CO feature to switch to another branch. Now, these are simple aliases. What you may not know is that you can assign a shell function to an alias. And in that shell function, you can have entire scripts that run associated to a simple alias. Now, one that I came up with a few years ago that I'm still using daily and I share with everyone is git undo. Now, this is a shell function. Let me show you how it looks like. First, I start my alias with an exclamation mark, which is telling it that it should interpret whatever comes afterward. It should run it as a shell command. It should just pass the string to the shell, in this case, bash. Then I define a shell function, which can be called anything. I just call it f. And in the body, I'm just doing a reset hard. However, this syntax over here is a parameter, because if you're defining a shell function, shell functions can accept parameters. So that means you can pass parameters to your alias and include that in the function. And at the end of the function, I just simply invoke it. Now, what does this do? Let me show you. Let's say that I make a commit. In this case, I don't want to make any change, so I'm saying allow empty. And I make a commit that says I'm about to regret this. And now I make another commit, also allow empty, and then I'm going to say and these two. So now, if I look at the history, I have two commits that I want to get rid of. Now, there is any number of ways I can do that. But if with my undo alias, I can say git undo, and it's like having the back button in your browser. How many times do you want to press the back button, or how many times do you want to press Control Z? Well, in this case, I want to undo the last two actions that I did. So I say git undo 2. And now, if I look at the history again, you see that those two are gone. So I've undone my latest two commits. And this is just one example of the many things you can automate by using alias functions. So, moving on, this is my favorite, reuse recorder resolutions. Now, let me first change to a different one. Now, when you work on a feature branch and you keep that branch around for a long time, and we are going to talk about it in just a few minutes, you are probably going to be rebasing it a bunch of times. And if there are any conflicts between your feature branch and whatever is in your stable branch, you will be resolving the same conflicts over and over, because a rebase is about applying each of your commits on top of the one you're rebasing on, one at a time. So if you rebase multiple times, you're going to be resolving the same merge conflicts. Now, Git has an automation feature built in, which is called re. Isn't it an awesome name? Which stands for reuse recorder resolution. Now, this is something you need to enable. So let's go ahead and do that. So you say re enabled through, and now it's enabled forever. By the way, remember that this just applies to your own repository, so everybody on your team has to do this. And now, so we are on the same project where we are on the feature branch. And we know from before that there is a conflict between master and feature. Now, when you're working on a feature branch for a long time, one technique that you can use to make sure that you are up to date with whatever is happening on the main branch is to do a so-called test merge. So let me show you how this works. And of course, you have this enabled. So I'm going to say, I'm going to merge master into my feature branch by doing a regular merge. So no rebase, just to show you. Now you see that right now, of course, we are running into the same merge conflict. However, this time, you see there is an extra line in the output that says recorded pre-image for that file. Now, the way re works is that every time there is a merge conflict, Git records both sides of the conflict. So it records how the line looks like on either side of the merge conflict. And what happens then? Then when you resolve the conflict, Git is going to remember or record what the final line looked like. So when it encounters the exact same conflict, it's going to automatically reapply your previous resolution. So let me show you how it works. So now we have a merge conflict, and let's resolve it again. So in this case, you see one side is removing the exclamation mark over here, and the other side is adding a comma. So this is the common parent. So let's decide that the final line is going to have the comma, but it's not going to have the exclamation mark. So this is how I want my final line to look like. So I save the modified file. Looks like this. Now, all I have to do, of course, is to add it to the index. And now I continue my merge. Let's just save this. And you see what Git says now? It says record a resolution for this. Now, yes, I have recorded a resolution, but if I look at the history, I now also have a merge conflict. And as we're going to see in a few minutes, this is not something that you want on a feature branch, because that complicates history, how history looks like. We're going to talk about it in just a few minutes. So I don't want to keep this merge commit around. So what am I going to do? I'm going to undo it with my undo alias. And now I'm back to however it was before without the merge commit. However, Git has recorded my resolution. So what happens if I merge master again? Now this time Git is telling me, hey, I had a conflict, but I have resolved it using the previous resolution. So let's take a look at how it looks like. Yeah, Git is showing me exactly how the lines looked like before and how they're looking like, how the line is looking like now. So it has reapplied my previous resolution. So at this point, I can just, of course, add this to the index and continue on. Now, the thing that's useful is that, remember, when a rebase operation is also a form of merge. However, you're just merging one commit at a time instead of merging two branches in one go. So this means that if I now were to rebase my feature branch on top of master, Git is going to reuse the same resolution even during a rebase. So of course it's going to stop because it encountered a merge conflict. However, if I look at the state of my working directory, you see that the conflict has already been resolved. So I can simply say git rebase. Of course, I need to add it to the index. And then I can simply say git rebase continue. And I'm done with my rebase. Incredibly useful stuff. The last one I want to share with you is client-side hooks. Now, every time you do something on your local repository and even on the server, like you're pushing commits or you are creating a commit locally, there are events that happen that Git is raising events for everything that happens inside the repository. Now, you can associate shell scripts that run as a response to those events. And why will you want to do that? Again, if you have agreed upon a convention in your team and you want to make sure that everybody is following that convention without adding more burden on their workflow, you can automate it for them. So you can distribute a bunch of client-side hooks that your teammates will have to download into their repositories, because sadly client-side hooks cannot be shared from a central repository. And then they will automate stuff for them. So for example, remember the white space checking. There is a client-side hook called pre-commit that happens just before the commit is created, and the argument of that hook is the changes that you are about to apply. So that's a perfect occasion to run a white space check just right before the commit is done. So it's going to stop if you are about to introduce any white space errors. The other one is another event that's happening when the commit is about to be created. However, this time the argument of the event is the commit message. And this is a perfect case to validate that your commit message is conforming to the rules that you have agreed upon. So for example, I have a, by the way, these commit hooks, they live inside the Git directory called hooks. There is a bunch of them. You have a bunch of sample scripts that are already made. So the way you activate it is you remove the sample extension and you write the code for the shell that you're using. So in this case, I have one called commit message that checks the format of the commit message. So let me show you how it works. Let's say that I want to make a commit, allow empty, and now I'm breaking the rule of making the first line be 50 characters. So this summary is way longer than the 50 characters that it should be. And now the commit hook has been activated and it's printing me, hey, the first line should be 50 characters, but yours was 70. What do you want to do? Do you want to modify it in an editor or just commit it? And of course, I'm going to say why, yes. And you see that even the editor is showing me that whatever is white, and many Git GUIs do this for you, they're going to highlight when you're past the 5th character in the summary, showing me that everything after that is longer. So this summary is way longer than 50. Let's remove that. And now my commit message is conformant to the rules. And with that, we are done with the personal workflows. Now let's go back and take a look at the team workflows. And these are, of course, also divided into 3 categories. The first one of these 3 categories is branching. Now, I'm sure you're familiar with all the different kinds of flows that exist out there. There is Git flow, there is GitHub flow, and there is whatever flow. Which one should you use for your project? Now, the answer you should be asking, that your team should be asking, is not which flow you should use, but rather, what do we need? If you've been looking at the original blog post for Git flow, the original author has published an update just this year in April or March, where he said that, yes, this blog post is 10 years old now, and basically saying what everybody already knew is that Git flow was designed and it came out of a specific situation. It was designed to conform a certain team constellation and a certain kind of software project. That's where it worked. Unfortunately, it became some standard that everybody and every team on Earth was applying this same workflow, regardless of whether their project and team matched the preconditions upon which Git flow was designed. So this is all to say that instead of focusing on taking a ready-made flow and apply it as is to your project, instead you should consider what kind of software you are building, and whether you have to maintain, for example, multiple versions in production at the same time, or you have just one version at any time, like in a web application. And of course, how many members on in your team and what their experience level is using Git. Those are all factors that have to influence your choice of flow. And the right answer is usually that there is no flow that you can use as is. You can be inspired by one or more of the different flows and adapt it to your specific needs. Now, when it comes to adapting a flow, what should you think about then? Well, one way to guide you in this choice is to think about what kind of branches do you use in a project. So be aware that there are a finite set of branches. What are they? Well, the first two kinds of branches are long-running branches, which are the branches that exist for as long as the project runs. For master is the canonical long-running branch. And then there are topic branches. Topic branches are branches that are focused on solving a particular problem or task. So they are short-lived. So for example, let's say that this is the history of a project. This is the master branch, the long-running branch that is shared among everyone. And then there is, from the master branch, you will be creating one or more, possibly more, topic branches that are focused on working on different features, for example. So these are the topic branches. Now, the way you merge the work done in a topic branch into the long-running one is by doing a merge commit. After that, the original topic branch is deleted, so there is no record of what the branch was called. However, you still have the merge commit to tell you that that work was done in parallel. The other kind of branches that you can create are public branches and private branches. Now remember, Git is a distributed source control system. So what does this mean? It means that you will be having a shared repository. Now, in Git, all repositories are created equal. There is no implicit primary or central repository like there was in a centralized source control system where there was the server. Every repository is equal to all the others. Now, you just so happen to agree on that one copy, one repository is deemed the canonical one, and you put it on a central server, like, for example, GitHub or Azure DevOps or whatever you're using. Now, everybody on the team is also going to have a local copy of the repository, a local repository, which is exactly the same as the shared one. So, and that will exist on their own computer. Now, a branch that exists on the shared repository, the one that everybody has access to, that is called a public branch. And any branch that you create on your own computer before you've pushed it anywhere, that is a private branch, private to you. Now, this is an important distinction to make because long-running branches, those are usually public because a long-running branch is usually shared. So multiple people are going to merge their changes into the long-running branch. A topic branch, on the other hand, that you create to implement a feature or fix a bug, those are usually private. So remember this association, long-running branches are public, topic branches are private. Now, this doesn't always have to be the case. You could have a private branch that you keep around for a long time. And as you have seen, there are things you can do to minimize the work you have to do to keep resolving the same merge conflicts. For example, by using rare. So you can, of course, keep around a private branch for a long time. That turns it into a private long-running branch. By the same token, you could have multiple people in your team be collaborating on solving the same topic. So for example, if you decide to create a branch for every user story, that if you're using some kind of agile process, so you're creating a topic branch for each user story, then it's very likely that more than one developer is going to work on that user story. And that means that you're going to be sharing the topic branch on the central repository, the shared one, and that turns it into a public one. So there can absolutely be topic branches that are public. However, these combinations are not the same. So long-running public branches, absolutely, that's okay. And private topic branches, that's also okay. However, long-running private branches, those are problematic for the reasons that we have been looking at. You're gonna the longer you keep a branch private, the more you're gonna stray away from the shared one. And even if you have features like rare, you will be encountering more and more merge conflicts to merge, like new ones. By the same token, sharing a feature branch between multiple people is also a problem. And why is that? Because a topic branch, remember the I in acid, incremental, you will often be reordering commits and squashing commit into other ones. So you will be rewriting history a lot in a topic branch because that's what it's designed for, to solve a particular problem. Now, if you have multiple people working on a topic branch and you do a rebase and you squash commits and you change the order, that's going to mess things up for the other ones. Because you know that every time you rewrite history, every commit gets a new ID. And if the other people working on the same feature branch have created new commits on top of the old ones, and then you publish your own rewritten commits, that's going to create a mess. So be aware of those combinations. So long-running public branches, yes, you should have them, but you should be limiting the number of branches that you keep around that are both long-running and also that are public. So branches in those categories, be conservative with them because they are a pain to handle. On the other hand, topic branches that are private branches, that's what Git is for. Creating a branch is a cheap operation, so you should be doing it like there is no tomorrow. So be liberal with those kind of branches. Take advantage of Git's branching model to be more effective with your work. So keep as many topic branches that are private as you want. Now that we've talked about different kinds of branches, we should also talk about different ways of merging. Now, the kinds of branches that you have decide the merge strategy. So there are, of course, two kinds of merges. There are the true merges, and then there are the rebases. So how should you merge these kind of branches? Well, the public branch, let's say you have a public branch that you want to merge into another public branch. In that case, you want to have a visible merge commit between them. If you're merging a public branch into a private one, then you want to have a rebase. So for example, if you have a pull request being merged into master, you want to make it visible with a merge commit. And if you are merging master into your own work in progress branch, then you want to do a rebase. And why is that? Well, if you have a public branch like this and you have a pull request, you're also public and you merge them, well, let's say that then something turns up that the pull request introduce a problem of some kind of bug. Well, if you have a merge commit, it's easy because you can revert that merge commit and it automatically reverts everything that came in with that merge commit. If instead you had rebased your pull request and done this kind of fast forward merge, and there is a problem with any of those commits, then you have to track them down and revert them manually. And the more commits that have been built upon afterwards, the harder it's going to be. So what you want to do instead is to, oh, by the way, why do you want to, speaking of rebase, why do you want to rebase your topic branch and not merge? Well, let's say that you are merging, like we did before, master into feature. And then at some point later, if you keep that merge commit around, you're going to merge this back into master. Now you see that history is going to look a lot more complicated than it has to be. And if you do this enough, your history is going to look like this, which is another way of calling it is Guitar Hero history. Why? Because if you squint, it looks like this. You definitely don't want that. Instead, what you want is you want to rebase your private branch on top of the public one and then do a fast forward merge for a nice linear history. Third one is releasing. This is a quick one. Now that you have multiple branches, different kinds of branches, different ways of merging, you should be aware of where the code that is in those branches is going to, which means every branch that is shared should be mapped to an environment. So that means that if you have a master branch and then you have another long-running branch called develop could be the place where you put work towards the next version of your software. So that in that case, every commit is going to a test environment where it's going to be QA'd. The master branch instead contains the stable version of the software that's currently in production. So when you merge the work that you have done in develop that has been verified in the test environment, you want to push it out to production so that your customers can use it. Now, the way you deploy from these branches is also different. Maybe in the develop branch, you want to automatically deploy every single commit so that it can be tested. In that case, you're doing continuous deployment. The master branch, you maybe want to be more conservative. You can be doing continuous deployment there as well. However, it's more likely that you want to be able to commit at any time. However, the actual commit trigger should not be automatic, but should be an explicit action that you do. And with that, I'm a few minutes over, so I hope you guys stayed around for the last part. I want just to summarize. We have talked about personal workflows, and among personal workflows is to get comfortable, configure Git to be a more pleasant tool to work with. Make sure to craft your history so that it follows the rule of ACID and it's nice and readable. And deploy as many automation features that you can to automate the workflow that your team agrees upon so that you don't have to think about it. Then we also talked about team workflows. And team workflows, they all are around the concepts of the different kinds of branches that you will be managing. So I was very intentional not to give you advice on which flow to use, but instead giving you guidance on how to evaluate the different kind of workflows based on the kinds of branches. And of course, once you have different kinds of branches, you also have different merge strategies. So being aware of how to handle those two. And the last one is being aware of how you want to release software from your branches, which environment they're going to, and how often are you going to deploy to those environments. With that, I want just to give you a pointer to everything that I've shown you and more is available on a Pluralsight course that I have out, which is called Advanced Git Tips and Tricks. This course includes a lot of what we've been seeing here and more. So here is a link to that. And with that, I want to say thank you for watching. And if you have any question, you can reach me at either one of those addresses or on the Slack I'll be monitoring for the rest of the day. As I said, thank you and enjoy the rest of the conference.